0, which is set on the screen.
Are they actually?
All right, we're not done.
Why?
So here's what we've got so far. Now, I want to make sure you understand something, and I think I'm going to rewrite this because I've gone back and forth today on how I wrote it, and I don't want to freak people out. Oh, that
Why
didn't
is
help.
there so much honey? Can you stop?
There. No, I've already calibrated today, and it didn't help. Okay.
These guys turning it off. Hello?
There we go. Okay. So, what we have now is we just have this with a c equals 0. Everyone okay so far? But they didn't ask for a sum of series, they asked for a series. Right? So, we have to learn how to combine sums. It's really not bad. There's a formula right here. And here's what it says. If you have the sum of a sub n x to the n plus or minus b sub n x to the n, it's just a sub n plus b sub n times x to the n. Now, there's a couple gotchas with this, all right? Number one, they have to be like terms, which means your x has to be to the same power on both of them, right? If the x isn't to the same power, then you have to adjust your n in order to adjust your exponent, right? But the n's have to be the same to add the sums. So what you might end up with, maybe in a problem or two, either tonight or maybe tomorrow, is say this was, say this was x to the n. Okay, say this is, just pretend, don't copy down. Say this is an x to the n, right? So we can't go to n equals -1, that just gets crazy. So keep this n equals 0. So I'm going to convert this to an x to the n. So I'm going to make this start with n equals 1. So this could be x to the n, so that they're equivalent. But now this one starts with 1 and this starts with 0. So what I'm going to do is figure out the 0th term, add it on the outside so that I can change this to an n equals 1 and then I can combine them.
What?
Right? Yeah. So we'll get there.
Why not just,
But-
you plug in any
why not just combine them with the x to the n plus 1?
Well, no. I was just saying, doing a what if. You know how you like to do what ifs?
Yeah.
Right?
So how would you
Yeah.
get
When
that?
you're in minor.
Okay.
So how would, if you had a to the 1 on the
Why not
bottom,
minor?
or sorry, yeah.
What's going on?
So
Okay. So anyway, so for this one, here's what I want you to think of. I want you to think this, you have an a sub n times x to the n. It's okay if it's n plus 1, as long as they match. And you have a b sub n times x to the n. It's okay if it's n plus 1, as long as they match. So your final sum is almost like 5 apples minus 2 apples, right?
Oh,
X to the n plus 1 is like your apples, right?
Orange.
So you have this many apples minus this many apples, and you have to write what's left. How many apples do you have? Right? So all you do is say I have -1 to the n over n plus 1 apples minus 1 over n plus 1 apples. So I end up with -1 to the n minus 1 over n plus 1 apples.
This feels like so pointless because you don't know like what to use it for, right? So like it's just like math for the
I'm
sake of
so
math.
glad these questions are all on video. So, yeah, I don't know. I am assured that it has a use. And I am assured that it is in engineering.
So we're not going
Not being an engineer. Anytime my brother come in, he's an engineer. He does
Guess
this
figure.
stuff all the time.
So what do you
Yeah,
know?
what do you do?
Notation from n equals n
engineers
to
low
infinity.
key just use spreadsheets.
I'm gonna ask my brother.
Wait, okay, this price. If engineers can use spreadsheets, why can't we use spreadsheets? I mean, we're both using calculators.
Because you haven't learned this yet, and they have.
They never use it.
right?
Yeah, it was great, said.
But what's the point in learning this if we can just use spreadsheets?
Brian, do you wanna get a
What's the
5
point
on
in
this?
learning anything?
Right.
Just do anything, right? Right? Yeah.
What's
You know,
the
what's
point
the
of
point
learning
of
this
reading?
use that?
Yeah, dude, why do we learn arithmetic if we all get calculators?
Arithmetic, yes, yes,
Yeah,
I agree,
exactly.
yes.
Medic.
Yeah, I just rolled into it.
Okay.
What about the average?
Way to go, Trez.
Chris, remember that one day that you saw everyone else?
So,
Oh, yeah.
that is true. If all books are audio, why learn how to read, right?
Exactly. What even is
Doesn't
reading?
Starting to get it.
Okay.
23.9.
Yeah, I don't think that's what I'm going to.
Well, it's like, I don't know how to do any math, because I could have a calculator wherever I go.
Yeah. Or series.
Okay, anyway,
We're off by
quiet. Class,
Yes, ma'am.
we're not done.
We're never
Okay.
done.
So here's the last thing we have to figure out, which is the interval of convergence. Now, when you have to do an interval of convergence, you can do the interval of convergence on the final series and get it, and it's fine. And you can do ratio test and you'll be fine. But there might be a problem here or there where the interval of convergence on the final series is too complicated, and you might be better off just doing each one individually. If you do each interval individually, the interval of convergence for the sum is the intersection of the intervals. Do you know what intersection means?
Yeah.
It's where what they have in common, right? I gave you a little example here. So I said, hey, so for example, if we have the interval -5 to 3 intersected is an upside down U, intersected with the closed interval -8 to 2, the intersection of the two sets is -5 to 2. It's where they overlap. All right? For this problem, because the -1 can be dropped, because remember we always put it in absolute value, if you ignore the -1, you end up with the same series for both, so they actually have the exact same interval of convergence. So you end up with an interval of convergence of -1 to 1 for both of them, just doing a simple ratio test. Yes, Claire?
Would it be necessary to do two convergence intervals and then combine them, or could you just do the interval for the final?
You could do the interval for the final and be fine, as long as you can do the interval for the final.
That'd be a huge ratio.
Okay, so, all right, and then you test the inputs, and there's your final answer, ta-da. Now, I'm gonna walk you through in 2 seconds what we did, and then I'm gonna bridge this to what we're doing, tomorrow, to kind of get into what we're doing tomorrow. So, just to recap, here's what we just did. We were given this sigma series, right? For 1/1 plus x. We used this to find a series representation for natural log of 1 minus x squared. Somehow you have to relate this to that. In order to just get started, we broke up the log, and then we saw, oh, look at that. If we took the integral of this, we'd get that,
Oh, dude.
right? And I can modify just a little bit to also get that one.
Is K9 in that one?
So then we've got our integrals, we replaced the expressions with their series, and then actually integrated the series. And then the only other thing we had to do was combine them. And then we got our final and solve for C, and then combine, yes.
So on the test, will it say use that power series? Or
Yes, absolutely it will. The test is actually very fair for this section. So it's, in my opinion, it's like excessively lenient for this section. Because he could go tough, right? But he chose to be nice. As a matter of fact, the way that he even organized the problems kind of walks you step by step through. So, yeah, it's very nicely done. When I took the test, honestly, I honestly thought, oh, this is really nice. Oh, look at that, it gets even better, right? So, as long as you don't, the problem though is that if you like mess up the first one, then you're sunk, right?
That's no pressure.
Okay, so anyway, just a little bit before we move to go to what have we learned. Tomorrow's warm-up is this.
Oh.
So all it says is, hey guys, rewrite arctan as a power series. So you're looking at this and you're thinking, what the heck, right?
1 over
There.
1 plus x squared.
Arctan x is the same thing as the integral of 1 over 1 plus x squared, right? We know the sigma for 1 over 1 plus x. All you have to do is square the x. You don't have to do anything weird.
Wait, is it
You
negative?
can literally take the x in your series, right, and replace it with an x squared, and now you've got the series for 1 over 1 plus x squared, right? So, and then you just do the integral, and bam, right? They're really not as bad as you think once you start getting used to them. It's just a matter of having your brain see the link between the two,
See on test day.
all right? And on test day, you're given this to start with, right? And so it won't be bad. You'll be okay, right? Okay, so here's what have we learned? What have we learned? So, can I, meaning can you, create a geometric power series based on a given function just like an a over 1 minus r? Doesn't that feel really easy now?
I love that
Good. Can you add or subtract two series together and find the interval of convergence of the sum or difference?
What is that?
Right? Good. Are you a bit tired?
No, I'm very
Okay.
tired.
Good. All right. Good. Good lesson.
Geez, dude.
Camera up. Why is it this class, it takes us like